Welcome to today's lectures, and this lecture is a continuation of identifying microorganisms in the tissue. So as pathologists, last time we studied about how you can identify microorganisms. So with the identification process, we have already looked at the type of microorganisms that find as pathologists. And also, we have also looked at how they demonstrate themselves or how you can identify them. So in this case, we said that we identify them by analyzing their morphological structure and forms. And apart from that, you can also use stains, that dye stains, to identify a type of bacteria or a type of microbe that is available in the skin. So today we want to look at ways we can prepare various things. So we shall mainly be considering gram stain. And after that, after looking at gram stain, to also look at Giemsa stain. So these are the two main stains that we look at how we prepare them. These stains are very important because they are for daily use. For gram staining, for instance, is not in the pathology lab alone, but in the microbiology lab, we use gram stain. The Giemsa stain is also daily used because of the presence of malaria parasites, plasmodium parasites, or any blood subsamples are also we use Giemsa stain to the thing. So now we want to begin the lectures by looking at gram stain. So when we talk of gram staining, we are looking at the processes, and we have already learned that gram staining involves our ability to identify two types of bacteria. That is, we want to look at gram-positive bacteria and gram-negative bacteria. So therefore, you need some processes to go so that if gram-positive bacteria is present, you'll be able to find it. Or if gram-negative bacteria is also present, you'll also be able to identify it. So going through the processes, we'll look at point one, how to apply the primary stain, that is the crystal violet, or the mordant, the gram stain iodine, and then rapid decolorization with what? Alcohol or acetone, a mixture of both. And after we decolorize it from the first primary stain, we also do counter stain. And the counter stain, we use saffronin or carboxyl. So these are the dyes that we, as a laboratory technician, you must be well confident of how to prepare this type of dye. So now we want to start how to prepare the primary. So we want to look at the primary dye, the crystal violet stain. So with the crystal violet stain, first you dissolve 2 grams of crystal violet in 20 ml of 95% absolute methanol. So it means that you get a beaker there. You need a beaker. Then after getting the beaker, you measure 2 grams, 2 grams of what? Crystal violet. 2 grams. It is in what? Solid. So dry powder. You measure 2 grams for sensitive fiber. Then you put it in a beaker. Then you also look for absolute methanol, 95% concentration. This is a stock solution. It's for sale, so you have it in the lab already. Like it. Then you pipette 20 ml, or you measure 20 milliliters. Then you add it to the solution in the beaker. The next one, you also find another beaker. Then you take ammonium oxalate, just 0.8 gram, 0.8 gram. Then you put that ammonium oxalate in what? 80 milliliters of distilled water. So it means that this one will also be what? In a different beaker of 80 milliliter. Then you dissolve this ammonium oxalate. The next one, you mix the two solutions together. The solution of what? 2 grams of crystal violet in 20 ml of water. So at this time, the total solution is what 20 ml against what 18 ml. So when you add this to it, it's going to be 100 ml. So you mix this in what in beaker, and you allow it to stay for what 25 degrees. So after allowing it to stay, you also have to do what you come to this point. You filter through coarse filter paper before you use. So as a technician, you must know the reason why you are supposed to what filter. You should know the reason why you are supposed to do filtration, because the reason is that the crystal violet was in solid form. Ammonium oxalate was also in solid form before we dissolve them in the various solutions. So there's a high probability that some of those substances will not totally or completely dissolve. So you need to filter them out so that when at the end you apply the dye on your tissue, those particles that were undissolved will not go and remain or also stain the sample for you. Else you have a false positive result whereby that particle will show up as if there was what a microbe that has been stained like that. So that is the main reason why you have to filter through a coarse filter paper. And then we are using coarse filter paper. In the laboratory, we have two different types of filter paper. We have the fine one and then the coarse one. The fine one to remove minute, very minute particles. So because we are working with color or dye, when you use the fine one, it is also going to interfere on the particles that form the dye. So we use the coarse one for that, this purpose. So after you filter it, you also allow it to work. So at the end, when you pass through all these processes, it means that you have been able to prepare your career. And for now, you can confidently say that as a lab technician, you have been able to do what? Prepare your dye, which is what? Identify the primary dye. So that is it. So after that, you get something like this. So you see the picture. This is what 95% methanol. That is for sale. This is a stock solution of what absolute methanol. So you take that one container of this and you put it in this big this flask. You put it in this flask. Then after you prepare your 0.8 gram of what ammonium oxalate, also put it. Then you place it on what magnetic stirrer. This magnetic stirrer will be shifting it gradually for it for everything to mix very well. So by the time you allow 25 degrees Celsius for I to see that that's so next we want to look at how to prepare the gram iodine mordants. When we say mordant, I have explained to you already that mordant, the main function of the mordant in the staining process is that it will fix the primary dye. If it was really absorbed by the microbe, it will fix it to remain in the microbe. So after your decoloration, still this color will not go. But if it was not absorbed, the mordant cannot fix it. The mordant cannot fix it. So after you do decolorize it will wash it away. That is the main purpose of the mordant. And the mordants to use what? Iodine. Iodine crystals is also in what? In powder form. So you measure what? Only 1 gram of iodine crystals. And you measure what? 2 grams of potassium iodide. Then these two, you mix them in a mortar. You add a little water. Then you grind. You see that all of them will dissolve perfectly. Then you put it in a beaker. So this you add small distilled water will be helpful in preparation. Then point three, we are aiming at what? Getting our whole solution to be what? 300 milliliters. Who at the end, whole solution should be what? 300 milliliters. If we take these quantities, that is 1 gram of iodine and 2 grams of what? Potassium iodide. We are expecting you that at the end of the preparation of the solution, you are going to get what 300 milliliters of the solution. So what you do is that in the laboratory we have different types of beakers. The beakers ranges from what 50 milliliters, 100 milliliters, 150. 200, 250, then 500, and then 1000 milliliters of volume. So because we'll be preparing 300 milliliters of what? Of this solution, the modern solution. Preferably, you need to take 500 milliliters of beaker so that at the end you have all your solution in one container. So when you pick 500 milliliters of beaker, you put this grind solution inside the iodine crystal and then the potassium iodide. You add little water, then you stir. After you stir for a while, you see that all of them will dissolve. If it has not completely dissolved, add a little water again. Then you stir and stir and stir and stir. Then after you have finished stirring, you top the whole quantity up to 300 milliliters level on the beaker. So after you do that, then you store at room temperature, which is 25 degrees Celsius. Then you also, when you are storing this one in the beaker, you have to cover it with aluminum foil. Aluminum foil, that is foil covered bottle, so that it will protect it from what? Light, exposure from light. This iodine is going to fix, it is going to fix the primary dye. So iodine is also what? Sensitive to light. So when we have allow interference of light with this iodine, it is going to destroy the potential of fixation of the iodine. So you have to cover it with a foil. And after you have covered it in a foil after preparation, another way you can also protect it from reacting to light is that you put it in what? In the deep brown bottle. When you go to the laboratory, you see that we have some bottles that they are not clear transparent, they are deep brown. The deep brown bottles, we normally put what? Solutions that are what? We normally put solutions that are sensitive to light in those deep brown uh, we normally put solutions that are sensitive to light in those deep brown containers. So after you do this preparation, then it means you are done with the product. So this is the setup of the preparation of the product. The first one, you start with this maker. This is 500, but on the label you see it is 1000. But if you take 1000, you can prepare. If you take 500 milliliters, you can prepare. The first one, you add your what? Iodine crystals, 1 gram of iodine crystal. Then you also add what? 2 grams of potassium iodide. Then you stir, you add a little water over here. Then you stir. When you stir, you see that it becomes saturated. So not all particles will be completely dissolved. So you add, you top it up a little. Then you stir. Then finally you add up to what? Your 300 milliliters level. Then you stir. After that, you cover the whole thing. You cover it with what? Aluminium foil. You allow it to stay. So with this, you are done with what? Gram iodine, which is more than you are done with it. The next one, we want to prepare the decolorizer. As a lab technician, I'm teaching you that you should know how to prepare all these things: the decolorizer, the primary stain, the mordant, the counter stain. At the end of this lesson, you should know how to prepare all of them. So we are now on the decolorizer, that is the acetone alcohol decolorizer. So this our aim is to prepare what? 1 liter. 1 liter. And when we talk of 1 liter, it is the same as what? 1000 milliliters. So now we start by measuring what? Acetone, which is 500 milliliters. So when we take 500 milliliters out of 1000, we are left with another 500. So you add either your ethanol or methanol. You add just what? 475 milliliters. 475. When you add that one, then you finally add what? Distilled water, 25 milliliters to the solution. So this 25 plus 475 plus 500 is going to give you 1 liter, which is 1000 milliliters. I hope you understand it. And as a technician, you must understand why we are using the mixture of these two to prepare the decolorizer. We are saying that when you use only one, acetone, acetone is very strong. So it is going to have deteriorative effect on the tissue that you are working on it. when you use methanol or ethanol, it is also going to have what? Another effect on the tissue. But we are saying that when you have a mixture of the two, when you dilute it small quantity with 25 milliliters of water, it works perfectly for you. It will be able to decolorize the stains that we have applied without having any detrimental effect on the what? On the teeth. So that is the more reason why we do what? We mix the two up. So that is how you prepare the decolorizer. Then next one, we come to what? Our counter stain. The counter stain, we are using saffron over here. And I told you, I have taught you already that with the counter stain, we can either use saffronin or carboxyl. But in this lecture, we want to consider how to prepare only what? The saffronin. So saffronin, we say counter stain. After we have decolorized the primary stain, then you apply what? Saffronin, so that if the specimen is gram negative or any part of the specimen that was not that did not absorb the primary color, the saffronin or the counter stain is going to what? Take out the color so that it will bring contrast. That is the more reason why. The next one, counter stain, you take what? 2.5 gram, 2.5 gram certified saffronin O. So the moment we say gram, you should know that that saffronin O is in what? It's in what? Uh, it can be in solution or it can be in a crystal or solid form. But you measure what? 2.5 gram. If it is in solution, you put the beaker on the sensitive balance and you measure 2.5 gram. If it is in what? If it is in powder form, you also take 2.5 gram. Then you dissolve this one in what? 100 milliliters of 95% ethyl alcohol. By this time, I know when we say 95% ethyl alcohol, you understand. So ethyl alcohol, you will measure what? 100 milliliters. Then you dissolve this 25 gram certified saffron. You dissolve it in it. The next point, what you do is that you add 10 milliliters, 10 milliliters of saffron again, and ethyl alcohol solution made in step one. This, when you take 100 milliliters, you take what? 10 milliliters out from what you have made in step one to 90 milliliters of dilute water. So it means that the preparation that you do in step one is your stock solution. So from your stock solution, you do another serial dilution. We call it serial dilution, meaning that you are taking the highly concentrated plant, just a few quantity or few volume of it, then you dissolve it in further water. So when you do that, we call it serial dilution. So you take only 10 milliliters, then you dissolve it in what? 90 milliliters of distilled water. Then next one, you have to store in what? At a room temperature. You store this one at room temperature. So this is your setup. That is 0.5 gram of food in 90 milliliters. So this one is what? The gram is what? So when you have your beaker like this, you mix it in distilled water, 90 milliliters of distilled water. Then you allow it for 3 minutes. Then you continue. Then it means that you have finished preparing. So the counter stain, this is carbofusion. This is carbofusion. So with the carbofusion tube, you take what? 0.3 gram of basic fusion in 10 milliliters of what? Ethyl alcohol. This one you are taking 0.3 gram of carbofusion. And then you dissolve it in about 10 milliliters of ethyl alcohol. So you add 5 milliliters of melted phenol crystal to what? 95 milliliters of water. So at the end, you are having solution in step one, and you have another solution in step two. So what you do? You add 5% phenol solution to the fusion solution and let it stand for overnight. So when it starts for overnight, at the end, you also filter to coarse filter paper. And I believe for this time, you know the reason why you filter with the coarse filter paper. Then next one, you store at what? Room temperature. You cover it in what? Aluminum foil. so that the color will not be interfered by what? By the light. And we are saying that this solution can stay in your lab for up to 1 year without having any added. So now we want to look at what? Giemsa stain. Giemsa stain. This Giemsa stain, we said it earlier, that it is also used for daily activities. So for Giemsa stain preparation, you take 1 gram of Giemsa powder. Giemsa powder, take 1 gram. Then methyl alcohol, you measure 66 ml, 66 milliliter of it. Then you have glycerin. Glycerin, you also measure what? 66 milliliters. And you put all these substances in what? In one beaker. Then when you add the glycerin to the ginger powder and put them in an oven, and then you set your oven to what? 60 degrees Celsius. So this one is degrees. This is the small zero you see there. It's supposed to be up to 60 degrees Celsius. Then you allow it for what? 30 minutes to what? 2 hours until you see that the stain has completely dissolved. This ginger powder, it takes a long time to dissolve. So when you put it in the alcohol, then you add the glycerin. But the alcohol will not go into the oven because alcohol is what? Highly what? It's highly inflammable. So this alcohol is not going into the oven. Be very careful. When you do that, you end up burning yourself. So it's only the glycerin and the ginger powder that will go into the oven, 60 degrees Celsius for 30 minutes to 2 hours until you see that the stain has permanently dissolved. Then after it has dissolved, you add your methyl. That is how we prepare ginger. So this is the process. So see the process over here at the Giemsa state, which is a stock solution. So there are some labs too that they also prepare it this way, and then they will be selling. So if you are fortunate, you find yourself in a lab that they buy it in this way, you are okay. You don't have to go through the procedure. You just have it this as your stock solution. Then you pour a little of it and you use it to prepare what? Your working solution. So in this case, you are free to work it out. Next one, you see the working solution that I'm about. So from the stock solution that we prepared earlier on, the stock solution that we prepared earlier, you do what? This is the stock solution. This stock solution that we prepare, you do what? You prepare a working solution out of. So you take the stock solution 1.5 ml, only 1.5 milliliter. Then you add methyl alcohol 1.5 ml. Then you dissolve it in what? 50 milliliters of distilled water. 50 milliliters of distilled water. So when you do this, it will be highly diluted so that you can use it to stain your samples. So after you stain, this is the interpretation of the result. Portion that will show blue, they are the nucleus or the nuclei of the organism. And then portions that will stay purple, they are what? The malaria parasite. Malaria parasite, that is Plasmodium parasite. Plasmodium falciparum. Plasmodium falciparum. And we have Plasmodium ovarium. They are all type of malaria parasite. So some of them cause different type of malaria. Have the malignant malaria, the tertiary malaria, or the passion. And then any collagen material, collagen and any other material. So as a lab technician, you must be what? Fully sure of this color interpretation. Where you see what? Blue is a nucleus, nuclei, and they are more. And then when you see the purple, it should tell you that the person is really suffering from malaria. And therefore, there are malaria parasites. And then other pink colors show what? Other elements of collagen. So that is the working of Giemsa. Next one, we are done with all the preparation of the test. So you must know as a laboratory technician, you must be sure of this the definition of this test. So first one, when we say stock solution, what is stock solution? Is it a stock solution? Is the solution stock solution can be defined as well, a concentrated solution of known accurate concentration that will be diluted for what? Further laboratory use. Further laboratory use. So you see, when we prepared Giemsa. We can calculate the concentration, so it has accurate concentration. So the first solution of Giemsa we prepared is our stock solution. So any solution in the lab that you will take and mix it with what, either liquids or other chemicals or distilled water before you use is what is a stock solution. So notice. The next one, we have what, working solution. When we say working solution, is the name given to a chemical solution made for what, actual use in the lab, made for actual use. So working solution is the solution that you actually use. So all the various things or dyes that you prepare, the one that you apply on the tissue or you apply for your stain is what we call the working solution. But the initial one that you prepared, they are the stock solution. So that is the difference between stock solution and working solution. Next one, you must what? Understand primary stain. When we say primary stain, I have said it over and over. The primary stain is a chemical used in differential staining in the first step. When we say primary stain, first step, to first step. This reagent colors all the cell of the microorganism being tested. After using the decolorizing agent, the primary stain may be washed or can be what, stained by the cell, which decide different categories of microorganisms. So you see, gram positive, we absorb it. Gram negative with what? We will not absorb it. So after applying the decolorizer, it will wash it away. So it is what? Crystal violet or methyl blue that we use for what? Primary stain. So examples of what primary stain can be what? Crystal violet or methyl blue. So in this lecture, I taught you how to prepare what? Crystal violet. So you should learn also how to prepare the methyl blue stain so that you can use it for other type of stains. Then next one, we have mordant. Mordant, I have said it over and over, that mordant, the main function of mordant is what? To fix the first color, the primary color. So we said gram iodine act as a mordant in gram staining. Use gram iodine. What we learn how to prepare. We use that one as well. A mordant also is known as what? Dye fixative. It fixes what? The dye. It's used to set the dye into the cell. Iodine has negatively charged molecules, which link the positively charged crystal violet. This trap the crystal violet in the peptidoglycan layer, also known as the cell wall. So it allows it to stay what in the cell wall. So you see, gram-positive bacteria, they have what very thick peptidoglycan in the cell wall. That is why they are absorb the primary stain. That is why they absorb the primary stain. So next one, we also have to know the meaning of this. This one I give to you as what reading assignment. Percentage V per V. That is percentage volume per volume. Percentage volume per volume. When you are at the lab, you see that they will write this inscription on some of the stock solutions that you buy. Stock solution that you buy, or even if it is what a powder form, they can write this one on it so that it will guide you on how you can prepare it. So when we say volume per volume, the volume concentration of a solution is expressed as what? Volume per volume, which stands for volume per volume. So the meaning is what? This is used when both chemicals in a solution are what? Liquid. So last time in the classroom, I taught you that we can have solution whereby two of them are what? In liquid form. So the one in smaller quantity becomes what? Your solute, which will dissolve in the highest quantity. So the one in smaller quantity, we have this volume. And then the one in highest quantity, we also have this volume. So when we say percentage volume per volume, we say that the percentage of the smaller quantity in the higher volume. So that is why we express it like this. So for example, when 50 milliliters of sulfuric acid is diluted in 50 milliliters of water. So in this case, both the solutions are what? Equal solution. But because this water is doing the dissolution, this water will act as well. It will act as the solvent, and this one will act as the solute. And we are what? Having a final solution of what? 100 milliliters. So 100 milliliters, it means that 50 milliliters is what? Just a 50% of the sulfuric acid in what? In this 100 milliliters. So that is the meaning of it. So therefore, we would express the concentration of what this solution as what sulfuric acid to be what 50% volume per volume. What it simply means is that 50% volume of sulfuric acid in what in the total 100 milliliters of what sulfuric acid in water. So that is the meaning of volume per volume. Next one, you must understand weight per weight. When we say weight per weight, so this is weight concentration of a solution expressed as what percentage weight per weight. So next one, like before, this stands for weight per weight. In this case, the volume of each chemical is what is regarded, and only the what only the weight is used. Only the weight. Only the weight. So you don't look at the volume. We put it on a sensitive balance, then we measure the weight of one solution. Then we put another beaker on a sensitive balance, we measure the weight of that solution, then we mix them. So in this case, we are expressing what weight per weight. We can also use it when we have what? So if the total mass of 100 gram solution is made up of what? So if total weight of mass of 100 gram solution is made up of 30 gram of hydrochloric acid and 70 gram of water, then we will express this as what? Hydrochloric acid 30% weight per weight. So this case, we are not considering the volume, but we are considering only their weight, even though they are. Then finally, we have what? Percentage weight per volume. Percentage weight per volume. So this is mass, also known as what? Mass concentration. If weight is the same as what? Mass. So mass concentration of the solution is expressed as percentage weight per volume or weight per volume. So it can alternatively be abbreviated as what? Mass per volume per what? Mass per volume. So this is used when a solid chemical is dissolved in a what? Liquid. So this one is a solid. We are measuring the weight of that solid. Then we dissolve it in a liquid. So this expression is normally used when we have what? Percentage weight per volume, that is a solid and a liquid solution. And also, if 1 gram of potassium iodide is used to make up a total volume of 100 milliliters, so 1 gram, which is a mass, solid, and then 100 milliliters, which is liquid, it is a volume. Then we say that we have what? 1% weight per volume solution of what? Potassium iodide has been made. So in this case, when you understand all of this, then we say that you are what? Very good laboratory technician. You understand your terms, you will be able to prepare solutions, states and dyes and everything, so that you can confidently work in any laboratory, whether we have pre-made solutions, states or dyes, or they are out of stock. You yourself, you'll be able to prepare it confidently with high level of what? Accuracy. So I thank you for taking this lecture very seriously. You can go through the video over and over, and the slides that I have sent to you, you can go through them over and over so that you'll be very confident with what? This particular topic. This is very important for me because you need this idea to work in various departments, either in the pathology lab, in the microbiology lab, or in the hematology lab. All of them, you need this type of things so that you use them. And you must be confident in preparing them. You must understand everything about them so that whenever you are working as a laboratory, you'll be able to produce what high level of. Thank you very much. Thank you very much for taking time to go through that tutorial. Thank you.